do? What am I supposed to be doing here? Presenting. There you go. I am a trained professional. I know exactly what I am doing. Now, got it. Yes. Screen capture. So it just captures the entire screen, which people who are listening to this in the future are thinking, just get on with the damn lecture. Okay, so we are going to do scientific writing and reporting today because you have, as you've got there from that sheet, you have your first assessment task in 3 weeks. And we will not be having formal lessons for the next 2 weeks. Basically, I'm on HSC marking for 2 weeks. So what you can do, no, that's fine. No, you're not. You have plenty of time. You have a study day on a Friday. You can come and see me, and I have plenty of free periods at the moment. After school, yes. So next Wednesday, I've got to be home by 4 o'clock to do the online marking. So what I'm hoping to try and do today is set you all up so that you can do all your literature review stuff in the next few weeks during the class time. And then when I see you on the 28th, we'll go to the library and we'll do our first assessment task. Because it's an online test. Yeah. Yeah, no, the literature review is not being marked. You'll be asked questions on the literature review. So the literature review has to be done so that you've got the skills to actually get to your thing there. Yes. Absolutely. Yeah, so I know, I see some of you in class and you know, some of you, who's got free periods now? Yeah, everyone. Yeah, but that's fine. So you can work, if you just make sure you work out a time to come and see me or put a question up on Google Classroom or whatever. So, of course, scientific writing is not what is on the screen anymore. Not many people would be doing all their reports and writing on paper or like that anyway with shavings everywhere. That's more like an artistic thing. So, I thought, let's just do a bit of frameworks here. A little bit of frameworks here. Science, as we probably told you in Year 7, Latin, scientia, knowledge. And so in the end here, what we are trying to do is get knowledge from you. Now, you should now also be starting on your portfolio. So the thing is, the way, and look, in all honesty, all the teachers who are teaching this, we're all getting our heads around it as well because it's a really different way of actually teaching. Because the syllabus isn't really, it's not really linear. Like there's all these little sections to it, but we're kind of grabbing little bits as we go. And when we get to analysing the data, and look, in all honesty, we'll muck around with data after the first task, just have a practice with a few things. We'll probably spend a couple of lessons in the library just working on the computers there, just mucking around. I finally got RStudio to work. I forgot to download something beforehand, so it was a bit of a numpty for a few days. So, first thing here, how do scientists journal the scientific process? Now, of course, we're doing this in a little bit of a stylized thing, and so what we're doing now, this is in Module 2, and so what we're doing is responding to coursework in written form. So what you need to be doing now is in your portfolio is just gathering information. Now, in the portfolio, at this point here, you can just be cutting and pasting stuff from the internet, as long as you're referencing it. And just remember, in Macquarie Fields, we use the Harvard referencing thing, okay? It's just the style we've got there. You look in the syllabus, I think, what is it, Harvard, APA, and Oxford, yeah. And you know what, the syllabus says all three. It doesn't matter. You just have to use one. Okay, we're going to use Harvard just because that's what you've been told since you started here in Year 7. And so the thing is, you document and maintain a scientific research portfolio. Now, I gave you some hints last week on how to set up your portfolio using the content stuff in Google Docs. That's a good way of doing it, but I don't know, is everyone going to do it in that, or is someone going to use OneNote or anything like that? I don't care. It doesn't worry me. As long as at the end, we can print it all to PDF so that it can get uploaded to NESA. And so the idea is record, and we go to this third point here, is recording and lodging the development of the research process. So some of you already sent me questions about, well, what about this, what about this, what about that? And I think most of my response so far has been, yeah, go with that, see where that takes you. Okay? And so you write this down. You say, I thought about this, I did some research on this. One of the key things, though, is in the end, you're going to have to analyse some data. Now, whether that's data you collect yourself or we use from secondary sources, it does not matter. You can use a combination of both. And I know, Lavasha, you were talking about microbes. Was anyone else talking about? Yeah. I've made contact with this place today, and I'm going to see if they can help us with that side of things. So we'll see what happens there. Yeah, and so we're at the point now where we're conducting our review of the literature. Now, of course, it is a really highfalutin term, but just saying you're doing some research, okay? And I think most of you have a bit of an idea of what you're going to do. And remember, you are not locked in to anything. You can do whatever the hell you want at the moment, okay? Cast your net as wide as possible. Now, of course, here are some other things here. So you've got to justify your research question. Okay, so what's justify mean, essentially? Explain, give reasons. So when you're justifying, you're also providing a bit of evidence behind it. Okay, and summaries. So what I would expect you to be doing over the next week or so, you know, if you go into all your sources, and I'm going to show you some sources later on, so I don't want anyone crying when I bring up actual research papers, because it's quite heavy, yeah. That's the nature of science. One of the things I can tell you is people who know science really good will often put the big proper words in there, just so they can feel a bit smarter. It works. So you've got to also be able to analyse, record data, represent. Now, record data doesn't mean you have to record it yourself. It means you can get the spreadsheet and do all that crap with it. Apply appropriate referencing protocols, so that's our Harvarding thing there, and make entries which evidence development. So you saw the way I set it up for you last week, and you set up with the headings of the H1s, H2s, H3s, and that will be really evident that you've got that logical progression. And also the reason I like Google Docs as well is if I really wanted to be mean to you, I'll go in there and see when you actually made those entries, which is a very good tool from my point of view there. So a lot of this will also come after the first task. Okay, so after the first task, once we've got area of research, we'll really refine our scientific question, and then we'll go into what data we can find. Okay, so the literature review. Now I know we covered a little bit of this last week. So this section, and this is directly from the NESA syllabus, which is free to get online. Inform the reader of the relevance of the scientific research includes background information, enabling the reader to understand the key areas involved. As usual, start the review with a broad scope and become more specific. Sources use current, where possible, original articles referenced rather than reviews of articles. And so I'm going to show you a little later some examples of scientific articles, and also some of the dangers of some of these as well. So the key thing here is relevance and the background information to it. So that way, what you're doing is you're justifying, you're backing up, you're showing exactly, you're showing the reader that you understand what you've done and you've come from a good point of view. The original articles thing is going to be probably the hardest bit, because when we have a look at a few of the journal search engines and that there, and there are plenty of free research articles out there, I think the hardest thing probably to be a scientist these days is actually finding the information, because there is so much. And as a scientist, you need to go, I think we made a joke last week about you go beyond the first Google page. It's the same thing with this here. And of course, stop me if you've got any questions. Okay. So broadness. Some of you said some big things. And so what we do is we start broad. So someone mentioned stem cells. Okay, so stem cells, your research, your literature review will cover stem cells widely a little bit, come back in, and then when we have a look and see what data we can get, then we can narrow it. So is there an influence of stem cells on this or that? And you know what? You can change. You can, when we do, like I want you to have the literature review finished within 3 weeks, but you might get to the end of the literature review and say, oh, I think what I'm doing, I can't actually research. That's not a problem. Change your mind. Because the idea of, and this will probably, hopefully it doesn't scare you a little bit, you can get to the end of this course and your, all your analysis of the data can show absolutely nothing. But that actually doesn't matter because you've conducted the whole scientific process. And a lot of scientists will tell you, oh, well, we've done years of research on this and we found that our entire hypothesis was wrong. That just means, okay, that's wrong, let's find something else. Or you're just waiting. Okay, yeah.
What if you come across a research article and it's really complicated and you can't interpret it?
Well, then, that might be a thing because when we look at some of the articles there's references to them. And so if you look through those references, you might find something. I'd suggest if it is really gobbledygook, don't use it, yeah. Or go back and say, well, okay, for me to understand what this is, maybe I need to go back and learn that bit there. And that's all part of the scientific process.
Would you recommend any websites to use for research?
I will get to that. Yes, we will get to that in a minute. Okay. So, read widely. Put as many, whatever the hell you read, put it in your digital portfolio. I do not care if you end up with 1,000 references, because it's just a reference list. It's better to have too much in there for your portfolio than because the portfolio is supporting what your final report. You're going to be marked on the final report. The portfolio, although we will do some work on that, will support everything that goes there. You're better for this, you know, it's the casting the wide net. Have as much stuff there as possible to start off with. And of course, remember to use your Harvard style. Harvard generator works perfectly. And I would also suggest maybe, if you can, although it's a bit archaic, maybe use some books or something like that. Although we don't necessarily have to, because if you're going to look at actual journal articles, you're not going to go to the state library and look through their journal section. Unless you're really bored on the weekend, you're probably not going to do that. You can access it that way. Okay? Most of the stuff we're probably going to access journal-wise is going to be online. Okay. Now here, I've just put a couple of things, and we'll just pull these up. These are just some examples of some more literature review stuff here. And don't worry, the links are all in the presentation. I haven't uploaded it yet to Google Classroom, but it will be tonight. I'll upload it at the same time I do the video. So here, just a little thing here. But I've given you a few different things here because they all have the same thing. Introduction, main body, conclusion. Okay, we look at this one here, which is UNE, which to me, I found it a bit easier to read. And it's the same thing, introduction, body, conclusion. Okay, and so this here, University of New England, is where I'm going to go with this here. So that one there is the same, that's the same one as that, yeah, sorry. And there is a copy of that there. So, introduction, body, conclusion. Now, that's a paragraph, that can be as many or as few paragraphs as you need. Depending on how well you're doing, 750 to 1,000 words is either really easy or really hard. I don't think, I can tell you from someone who's written books and that, there are days where I've gone way over when I'm writing something and I've got to have it in 1,000 words, and there's days you get to 250 words and do the word count. Oh, crap. Okay, then the next one you do it. Oh, it's only 300 words. So, just go a bit nuts there. It also tends to, now remember, your introduction is explaining what's happening, your conclusion is explaining all the sort of the rest there. Most of your data and stuff like that is in your body. So, from the UNE thing here, so the first thing is the literature search. Now, remember last week I said, don't be afraid. For your initial search of things, look at Wikipedia. Look at the footnote links or the references down the bottom of the Wikipedia page. Sometimes that'll take you to a journal article. Sometimes it'll take you to something else. Sometimes it'll be a dead end. It doesn't matter. Find the literature. Now, finding the literature we'll have a look at here in a second. Read it. You know, once you've found it, you should read it. And write short summaries. Now, this is a skill I think we as a school probably haven't helped you a lot with in terms of doing this as a study skill. So the idea is that if you read the journal article, you should be able to explain what it's about in 3 or 4 sentences. Okay? Which seems either like too little or too much. But like the key to understanding something is that you can explain it really simply. Okay? It shouldn't take a lot of explanation. Yes? So one might be, you know, so match it 2018, blah, blah, blah. Study habits of students in year 12 showed that there was a 10% increase of student retention of information by using this technique. So it's not going, it's summarizing the stuff really quickly. Yeah. So you just quote what the article was and say, it showed this. Now, there's a few dangers in that which we'll talk about. Organize the summaries means you put it in a logical order. So you don't talk, if we were going to do it on student study habits, your first paragraph in the body wouldn't be, this method led to an increase of 20% in student marks. You'd probably say, first of all, yeah, what the study habits were, and then say this leads to that, to that. But it's just good essay technique, really. You just put it in a logical progression so that the reader doesn't suddenly say, well, where the hell does this information come from? Oh, it's come from here and here and here and here and here. Yeah. Okay. 750 to 1,000 words. This doesn't have to worry about your references. Your references can be separate. Because yeah. Just remember, you will have a copy of this later tonight. Okay. Now, I'm going to very quickly, and actually I've already opened this in actually no, we'll just open it anyway. This is from the University of Melbourne, is it?
In this video on writing the literature review, we're going to look at what a literature review is. We'll look at some of the language you can use to write your literature review, and we'll look at some example text. In the video, I'm going to ask you to do some reading and do some considering of examples. So at times, I'll ask you to pause the video to think about some questions or do some reading and to reflect on some of the issues around writing the literature review. First, some questions. What is a literature review? What is the purpose of literature review? And what does one consist of? Stop the video now, write some notes in answer to those questions, and reflect on some of the answers as we go through some of the ideas in this video.
Okay, so what is a lit review? Summary of the main ideas. Purpose. Introduction. Well, and we talked about last week, we said like to know what is known. Okay, so you know what you know. And what's it consist of? Body, the introduction, conclusion.
First of all, defining a literature review. Pause the video and read this definition from Ridley. There are 3 key things I want you to take from this definition. 1, there's extensive reference to related research in your field. 2, connections are made between those source texts that you draw on. And 3, you position yourself in relation to those works that you read. So, the literature review starts with the reading, and the person who needs to evaluate the sources is you. How do you do this? One way is to consider the authorship. Who authored the research? Are we talking about someone who's expert? Is it relevant? Is it academic? Does this person have standing in the field? The other way you can judge the type of sources you're looking at is where they come from. And what we're looking for are sources which are peer-reviewed, academic, expert, trusted, published and written. Here's a question. Journal articles are often preferred for literature review in an academic context. Why is this? Think.
Okay. Now, that's a really, really, really interesting point there. Most of the time, you're going to look up these things and you've got no idea who that person is that's written it. Now, when we look at some of the examples, you can click on their name and it will pop up what other journal articles they've written and what other stuff they have been involved in. The second one, the source, is actually I think is a little bit trickier. Unfortunately, there is a lot of academic malpractice. Research has unfortunately become a very competitive field. There's a lot of talk from university academics, which is this idea of publish or perish, which means that if you don't publish articles, you may lose funding. And you lose funding, you don't have a job. And the academic, expert, trusted, published, written, documented, the academic papers can be published online. They don't have to be published in a magazine, which is the way it used to be. And there are problems with magazine publishing as well, which we will talk about soon. Yes?
Sorry. You said, sources being peer-reviewed. Does that mean we'd have to, mention, validity, reliability, and,
That's a few slides in. Yes, we will. Yes, you do. Yes. Validity. So what you've got to do, you do have to make a judgment on the validity and the reliability of the data they present. Now, look, I don't think at our level, you don't have to dig all the way in there. But yeah, if you're an academic writing a paper, then yes, you do have to do those checks. In general, what happens? So, one of the biggest science. There's a I can't remember if it comes out of England or the US. Science is one of your big science journals. I'm going to talk later on about one of the biggest medical journals, comes out of England, called The Lancet. And so what it is, it's a it's a journal that's been around for hundreds of years. And so what happens is that they have teams. So if you present a paper on immunology, then they will give that paper to however many immunologists who will read through, look at your data, and say, oh yeah, that's really good. That makes sense. And so that's what peer-reviewed means.
So if you find peer-reviewed things, that's definitely the most reliable.
In terms of this academic stuff, it should be. It's not always, which we will talk about. So, and that's the thing. You guys are not doing academic research at university. Doesn't mean you can't go into this a little bit, but don't get bogged down completely in the validity and reliability. Okay? You do need to make a judgment, but it shouldn't be the be-all and end-all of what you're doing.
Think about that. The answer's in front of you. It's because journal articles are peer-reviewed. They're academic. They're written by experts. They're reviewed by peers of the people who have written them. That's why they're preferred. So, you've started the reading. Now, there are some larger questions you need to ask yourself as you're reading. And I'm not just talking about who wrote it, what they found, what they did. I'm thinking about some of the larger, critical questions that you can ask yourself as you read. And here are some of them. Who are the researchers? What's their reputation? Do the findings support the research? Are there any biases evident? And perhaps the biggest one, the biggest question, is it applicable? Is it relevant to your work? The key thing is that the research, the critique, starts with the reading. So, you've started reading. Now you've got to think about how you can group your notes, how you can organize your notes. There are a number of different ways. It depends on your questions. You might organize them chronologically by time. You might organize them by the perspectives of different authors, the positions taken, the schools of thought, the method, how they did the research. Or most commonly, you might organise it topically or thematically.
That's the way we're going to look at, like, basically the essay style thing. But the essay can sort of also incorporate those other things depending on what you're doing.
Like an essay. So it's really important to note that whatever organisation you choose, it depends on your research question and the aims of your study. Ultimately, you have to synthesise the ideas and respond to the text. So, a tip, create a plan, a sectioned plan as a document, and as you read, take notes and import them directly into the plan so that you have a sense of organisation and section as it happens. On to the writing component of the review. There are two key elements. One is a descriptive or reporting element, where you talk about what happened. You describe what the author has found, what they discussed, what they did. It's an account. The second crucial aspect of the literature review is an interpretive or critical element, the dialogue, where you ask and answer questions of the text. You analyse, you interpret, you synthesise, you bring together information. The second part is super important because if we just stay at the first part, the descriptive reporting element, we run the risk of having our writing grounded in a shopping list style of writing where we're saying, he noted, he found, she did this, she discovered. It becomes a list of ideas rather than an interpretation or a treatment of ideas, which is what a review is. So, how do we do this? How do we move our writing from the descriptive to the interpretive? Look at this example. Take 30 seconds to read it and look at what's going on. What you can probably see, as suggested by the colour we're using, is that the first part of this is descriptive. It's what Evans showed. The second part is interpretive.
Okay, so I think that's a really important point for us. So when you synthesize your information, you say, this is what this shows, this is what I think it means, this is what it... Okay, and so what that will do is that'll inform what your potential next question is going to be. Okay?
Because we're saying here, Evans showed this, the method was successful, and this was significant because... Let's look at another example. Take 30 seconds to read this again. You'll see a similar thing going on. We have a descriptive element, Weng et al. Found something, and then an interpretive element where Bruce argues why these findings were crucial, why they were important. So when we're using this language, this was significant, this was crucial. We're flipping the writing, we're moving it from descriptive to interpretation, the critical component. And there's language we can use to do this. Language we can use to highlight importance, to interpret, to give us a voice. This shows that. This is important. This is vital.
Now, I'll give you a little bit of it. This sort of language is also going to help you with your other science courses. Because I can tell you one of the key aspects that particular students in this school do, I'm not going to say badly, but don't do as well, is you can give me a really good set of facts, but you've got to, what's that mean? Okay, so I think that's a good skill for you to develop as well. This is what it shows, this is what it means. Okay, and so these things here, like this shows that, what this means. This can be illustrated, which points to, which is vital. Particularly in the HSC the last few years, there's been a lot of questions across all the courses. And it's like, you probably had things like compare and contrast, a lot of questions. But there's also in questions, which is, to what extent does this impact on that? And so it's interpretation, it's doing that there, which I think is a good skill for you guys to develop.
This points to. And this language is important for two key reasons. One, it moves your writing from the descriptive to the interpretive. And two, it gives you a stronger writer's voice. It's you talking. It's you giving interpretation. Another element of the lit review is responding with critique. So let's look at another example. As I give you these parts of the paragraph, read through them and look at what's going on. It's a layered approach to writing. The first layer, again, shows us description. It's what Brent found. A second layer reveals some critique going on. And again, we have was limited in its application. This is some sort of deficit critique showing a limitation of Brent's work. Then we have a third element. And what you can see here is now we're offering a solution. It may have been more illustrative to do X, Y, and Z. And in a...
Okay, that makes sense there. So the idea is here, this is what was found in the paper. Critique means, and critique is not saying it's wrong. It's just giving, just saying, in this case here, it was limited, okay, because it's a small sample size. And then your solution, which is, well, okay, if we want to show this, maybe you need to broaden it and look at this, and this. This is actually an important factor to what we'll talk about in a few minutes.
A final bit to that, we have another critical part, but this time it's a positive critique, pivotal, longitudinal, multi-facility, broad scope study. So we have layers to this paragraph. Description, critique, solution. Let's look at some of the language of critiquing. We can have deficit critique.
Okay. I'm going to just stop it there. If you want to, like, did I put the links up to the videos? If I don't do it tonight when I put up the video, tell me about that there. Because I do want to get onto this next little bit here. Okay, so that was our video there. One of the things you may have seen, and it's become popular, Google Scholar. Google Scholar is basically a Google search engine for articles. Okay, and so I just did a quick little thing there, and I typed in platypus. For no reason, then just platypuses came to my head. And then it came up, and I thought, oh, platypus venom. Okay, because I assume everyone knows the male has a spur on its hind legs, which is poisonous. And you don't realize platypuses are only about 30 centimeters long. They're tiny little things. But that doesn't matter. What else is unique, biologists, about platypuses? Monotremes, yes. Yeah, one of two eggs. What's the other one? There are two mammals, platypus and? Yep, good. So, when you look in Google Scholar, it gives you a whole list of things here. This is just a screenshot. One of the things, if you click on most of these, you'll probably just get the abstract summary. Now, that might just give you a little bit of understanding. Every so often, though, you'll see this one here, full view, okay, which is the entire article. If you look, there are plenty of places you can find that there. And so this one here, this is where there you go. And this is where it's really easy to get lost in this. So this is about platypus venom, the D-amino acid residue, and the C-type natriuretic peptide from the venom of the mammal. I'm not even going to try that. That's basically just a platypus. But, it's the meta-language in these papers is, these are guys and girls and everyone in between who have been spending, what do you got? You've got your 3 years undergrad science degree, then 2 years master's, and then 2 to 3 years PhD. These could be people on their master's and PhD. They've been neck deep in this science meta-language for at least 5 to 6 years. So you would hope that they'd pick that up by then. Okay, so this is another little thing I think I'm asking you to possibly consider putting in your process, in your journals. A glossary, depending on what you're doing, a glossary might actually be a really good thing there. Now, if I was going to look at platypus venom, because I think platypuses are kind of cool, and the fact that they can, I don't think the venom kills you, it just stings you. So I'd probably start putting in the words. So start building up a glossary. you know, if nothing else, you've learnt some really cool words that you can just drop in your biology or chemistry or physics exam or whatever you've got there. Okay? So, if nothing else, you can look cooler in front of your nerdy friends. You know, how many of you go to tutoring? Yeah. So, here I have as well is some links. Now, one of the biggest ones, now Google Scholar I just showed you here, one of the interesting ones here is PubMed. This is probably the main journal repository for basically medical, biological things there. So, and you can search, well, there's a whole heap of stuff you can get in there if you want to. But let's just stay on PubMed for the moment. Give me something biological. AIDS. HIV/AIDS. Do a search, and you get all of this stuff here. Now, depending on what you've got here, let's... Which one? That one? Okay. Yeah. Now, a couple of little things, and I've got to thank Dr. Bajaya for showing me this because I was looking. Yeah. When you get on PubMed, if you look over here, full text links. Click on that, and after going through a few little things. And if you click on one of those there, you will eventually. Okay, this was a bad one. This one doesn't actually. Yeah. But look, we can go through there if you're interested about. Or no, let's not bring up scrotal abscesses and syphilitic. Yeah, we don't. Syphilis and scrotums. Yeah, let's not go there. Well, here you go. Aging with HIV, because in Western society, most people generally don't die of HIV anymore. It's very rare for people in the West to die of HIV because the antiviral treatment is so strong. It is still a huge thing in third world countries. Well, you know, really good example would be, this is in Spanish or something. So if you can read Spanish, we could translate. But yeah, you can go through and eventually you will find a lot of these things there. Yeah, it's only in the third world that generally people die of AIDS because they can't afford the retroviral drugs. You know, Magic Johnson, basketball players, had AIDS for 30 years. And apparently he's healthier than when he was playing basketball. Because AIDS doesn't kill you. What kills you is your immune system dying. So if the antivirals stop your immune system from... No, most of the antivirals suppress the, and I am reaching into the depths of my knowledge here, because it attacks the T cells, and so, see, some people, yeah, and so what it does, it stops the T cells the antivirals stop the T cells being destroyed, and so your immune system still works. So most of the people who die from AIDS, it's from symptoms, like it used to be Hodgkin's lymphoma, which is a form of skin cancer. And it was a form of skin cancer because the skin wasn't able to repair itself properly. Or you can challenge me on that because I may have just made that up. So Google Scholar, we just had a look at an example here. We've got here the directory of open access journals. This is actually a good one here because pretty much all the articles here are free. Hence, open access. Yeah. Oh, and if you can speak Turkish, they want people for jobs. That was interesting there. So, and this one here is pretty good as well. You can browse by subjects. Keep in the science area though. I don't want a history of America. Just remember, you can become a doctor in anything. in science. All it is that we, although it is, don't know why, I know it's down there. No, I'm not. No. I don't even have a master's.
So
No.
you can just give straight to PhD.
Nah. No, look, I do take my... No, I'll get a PhD from one of those theology places in Texas or something that you can order online. So just another one here. This is just... Now this one here, the Elsevier Open Access Journals. Again, fully peer-reviewed, all of that there. Now, of course, what I want you to have a think about. Here is an example of... Yes. This is an article on multiple sclerosis in Australians, an investigation of polymorphisms in the CC. Multiple sclerosis is a degenerative disease where the affects your spine, and so the nerve, I think it's the myelin sheath around the nerves. So it's a protective sheath around the nerves. It starts breaking down, and so when it breaks down, it goes in. What it does is, I think it stops the electrical signal in the nerves from going in the right path. And so MS can be it can be real, it affects people differently. In some people, they experience mild symptoms for a long time. In other times, other people, it affects them severely in a short period of time. I don't think it's a really well understood disease. And that's the thing with any of the neurological diseases. They're very hard because, it affects the body so much there. So, of course, if you read through this here, multiple sclerosis disease, central nervous system, see, I am smart, and all that there. This one is actually quite easy to read, and if you come down to the science staff room, you can even talk to the author. Yeah, so these are, I'll put some links in there. Oh, no, these are 3 of his research papers. Yeah. Yes, that's why he's a doctor, because he's got all these journals. That is your bio teacher. You can praise him tomorrow. But you can see here that these are actually good examples, because you've got to hear the abstract, the introduction, and they're actually not that hard to read, these ones. And, you get there, and this is the paper, and you can see all the data there and that there. And you think about, I think this is a couple of years' work. It just gets all summarised in this little paper there. And so this is a paper that's been peer-reviewed, it's been accepted, and that there. Yeah, and there is one more on here. Analysis of the... Yeah. But one of the things there, and it was reading through these that I had the idea. I think, look, if you're reading this here, you need to know what these words mean. So you need to know, okay, you can write down what a gene is because you're all pretty smart. HIV susceptibility, so that says how easy it is to catch it, and disease progression, how quickly it progresses. And so that's why I made the point before that, in the Western world, if you are diagnosed, you can get treatment. In Australia, I think it's on the pharmaceutical benefit scheme. What's that? There is, I think I read an article earlier this year talking about the fact that there is a vaccine.
Oh, no, it's malaria.
Malaria, yeah. The problem is, it is a viral thing, and once you've got a viral thing, it's very hard to get rid of it. Now, I do need to make a thing here. Now, we mentioned before validity and reliability. We just had a look at some articles. They have all been peer-reviewed. They have gone out to other scientists who have said, yes, this is good, yes, 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 yes. You would, as starting out in your scientific research journey, would say, well, it's peer-reviewed, it's published, it must be accurate. The Lancet, I mentioned before, the Lancet is has always been considered one of the most respectable medical journals. However, they get it wrong. This is an article in the Lancet that has been retracted. Yes. No, it doesn't. Now, this is an interesting thing here. And I'm going to say this wrong. Allele lymphoid nodular hypoplasia, non-specific colitis, and persuasive development disorder in children. In English, I can't do that off the top of my head. Non-specific colitis is that you've got nodules in your rectum, like little lumps and stuff like that. And pervasive developmental disorder is their fancy way of saying autism. Now, this is what caused that whole thing about linking autism and vaccines. Now, it goes on for a few pages here. It goes on, there's all this data and all this here. And you think, this is published in a medical journal. Yes? It's wrong. It's wrong. So when, and this is a really interesting thing about the scientific process as well. You publish your things, and you're not always right. You are not always right. Now, this was retracted. It's got all this stuff here, all this data, discussion, pictures of kids' rectums. It's in black and white. It's all good. Well, that's just a bit of tissue that's under a microscope. But all this stuff here, all these references. However, I would suggest, I want you to read the first two paragraphs and tell me why you think you should be suspicious of this article. An exceptionally small sample size. Now, 12 children. Yeah, so 3 to 10 years old with a mean of 6. There was one girl there. Now, even you guys can sort of pick up that a sample size of 12 is not really reliable. It might be a starting point. You might say, well, okay, it is a bit suspicious that there's 12 kids that have developed autism, or I think they only say 10 somewhere. Okay, 8 out of the 12 developed autism. And we shouldn't actually even use the word developed autism because it's there. But this is a thing that is still persuasive. It's still what is used by a lot of people around the world to say there is a link between autism and vaccines. Despite the fact now that the vaccine now occurred, because part of the reason it happened, this is 1998, the diagnosis for autism happened around the same time as the MMR vaccination. That was where they started their thing. Now the diagnosis for autism actually happens before it. So kids get autism or are diagnosed as autistic well before the vaccine. And so their argument was that the vaccine caused inflammation in their lower colon, and that inflammation somehow caused this to happen. Now, it's very easy to get out on a high horse now and say that that's incorrect and blah, 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 but it is an article. If you were looking at this 20 years ago, you would probably say, well, it's in the Lancet, it must be valid, it must be reliable, it's been peer-reviewed. So take peer review with a bit of a grain of salt, okay, because it's critical, yeah, and I think, again, that's a really good point, that if you get nothing else out of doing extension science, you're critical thinkers, okay? Basically, don't believe the crap you see online. Comic Sans. Comic Sans is one of my favourite fonts. Okay. So, of course, you see here, there is autism, yeah. And you can see here, even some of them, it's like, oh, maybe it's autism. They've had the MMR. And, look, in all honesty, I think this is probably an article that's caused more damage to kids. Last week, there was an outbreak of measles in the Sutherland Shire, around Miranda and that. No. But there is this cult of anti-vaxxing. And I'm sure I've seen people, I try not to argue with people online, but I've seen people get very angry and upset about it. It is a little bit like that, but, 20 years ago, kids in Sydney would not get measles because, ever since I was a kid, they've been vaccinating for it. You get it. It's very rare. And there's a thing called herd immunity. You need I think it's about 95%. I'm probably wrong, but if you have 90 to 95% of people vaccinated, that actually protects the 10% who aren't vaccinated. Now, there are people for very good reasons, like they've got immune deficiency things that cannot be vaccinated. So what has to happen for them to be protected? Everyone else who can do it should be vaccinated. We don't have smallpox anymore. We rarely get Black Death and crap like that because for the most part, people are vaccinated against these things. And it does cause a lot of things there. So I would, and this is going to be my last point, these are jokes. So first one there, don't blame me, it's my mum and dad's fault. 30 years ago, if a kid in the neighbourhood got measles, the other kids would be forced to play with them. They used to have these pox parties. Because the idea was, because measles, mumps, rubella, all these diseases, you get them as kids, your immune system's still really, really strong. If you're an adult and you get the mumps, the mumps, particularly in males, can actually, let's just say, destroy parts of your body you don't particularly want destroyed. Because mumps can affect nodes in your body, and one of the big areas that mumps affects is in your groin. So if you haven't had children and you want to have children, do not get mumps. Okay? And of course, the last little one here, I trust the movie actor more than you. There is a whole heap of... And those of you in investigating science, just wait till we do fact and fallacy and we start talking about Gwyneth Paltrow. No, let's not go jade eggs. No jade eggs, please. No jade eggs today. I'm going to turn off the video before anything goes there. Okay, any quick question?